Hey everyone, welcome back to my channel, and in today's video we will discuss the problems asked by Tech Mahindra in SUPERCODER test. Remember that you will be able to attend this test only if you have performed really well in all the rounds of the hiring process, and you must receive the following mail by Tech Mahindra. In the SUPERCODER test you will be given two problem statements which you need to solve in around an hour. Let's look at the first problem. Long story short. Imagine your friend has been captured by Mr. Jason, who has placed a collar around his neck. The collar is locked with a special locking key, and the only way to remove it is by finding the correct unlocking key. Your friend has seen the locking key but doesn't know how to find the unlocking key. To help, you realize that the unlocking key is simply the smallest possible number you can create by rearranging the digits of the locking key, making sure it doesn't start with 0. Now, it's up to you to figure out this number and save your friend. Let me explain it to you with some examples. Suppose the given input is 756, then its smallest permutation will be 567. If you observe, in order to find the smallest permutation we only need to sort the number in ascending order. Quite easy, right? You must be thinking, oh, we can convert this number to a string and then sort these characters and then again convert it to an integer and return it. Right? But there's a catch. What if the numbers are negative, like this one? Well, in that case the numbers need to be sorted in descending order with the negative symbol at the beginning. Also, the leading number cannot be 0, which means when we sort a positive number like 7065, then 0567 is not the actual answer but the correct answer is 5067. We will handle this case in the code by swapping the first non-zero number with the 0 at first position. Let me walk you through the code. We need to complete the function unlock key and return our answer. First, we will check if number is negative or not and then solve both the cases differently. We will convert the lock key integer to a string in order to easily sort the number and iterate over it. Then we check if the number is negative or not. If it is, then we skip the first character, which is a minus, and sort this string in descending order as it is negative number. If it's not negative, then we sort the string in ascending order and loop through the string to swap the 0 at first position with a non-zero character. At the end we again check if initial lock key was negative. If it was, we add a negative sign to our answer variable and return the answer. Now, let's look at second problem. The problem is quite long to read at once, so let me explain it to you in short. Imagine you have a city with several pickup locations where passengers can be collected. These locations are scattered around the city, and you have a base location where all your vehicles are parked. Now, you need to connect your base to each of these pickup locations using straight lines or routes. But, to save costs and simplify operations, you want to minimize the number of different routes needed. Let's say your base is at 0, 0, and you have 3 pickup locations. Pickup 1 is at 1, 1. Pickup 2 at -1, 1, and Pickup 3 at 2, 3. Imagine drawing straight lines from your base at 0, 0 to each of these pickup points. You want to count how many unique lines are needed to connect to all these points. In the example, a line from 0, 0 to 1, 1 covers P1. A line from 0, 0 to -1, 1 covers P2. A line from 0, 0 to 2, 3 covers P3. Since these lines have different slopes, which means they are not parallel or overlapping, you need 3 different lines, and that's what we need to find. But what if we had some more points like these, -1, -1, 1, -1, and -2, -3? These points perfectly overlap with previous points because they have the same slopes, and hence the number of unique lines still remain 3. Now, to solve the problem we need to calculate the slope from the base to each pickup point. Identify unique slopes, which means different directions. And the count of unique slopes gives the minimum number of routes needed. This code calculates the minimum number of straight line routes needed to connect a base location to several pickup locations on a 2D plane. It first reads the coordinates of the pickup locations and the base location. For each pickup point, it calculates the slope of the line connecting it to the base and reduces the slope to its simplest form. These unique slopes are stored in a set, which automatically removes any duplicate lines or same slope. Finally, the size of the set gives the minimum number of unique routes required, which is printed as the result. That's it for today's video. I have posted this document in my Telegram group. You may join it, download the document and get latest updates. Thanks for watching and see you in next video.